Hi friend, today I am going to discuss about measurement event A3. This event A3 will used during handover procedure in 4G and 5G also. So we should understand event A3 to understand the handover procedure. So I want to discuss about A3 event and when will trigger and when cancel and what criteria. So we can discuss A3 event configuration. E-node we send to the UV through the RRC reconfiguration, and I take in this event A3 from RRC reconfiguration. We can see here event ID event A3 offset is equal to -20, -20 is equal to -10 dB. Here in a parameter level, integer value is defined 1, 2, 3, 4. 1 means 0.5 dB. For so here -20 is equal to, if we calculated, then -10 dB, and here hysteresis is 4 is equal to 2 dB, and time to trigger, 640 millisecond, trigger quantity RSRP, and report quantity both, and max cell 8 and report interval 500 120 millisecond, report amount 1. So we should understand trigger quantity means A3 event will trigger on the basis of RSRP only, but report quantity is equal to both, means when we will send measurement report against A3 event, that A3 event, in this event, RSRP and RSRQ value both will be available, and so max cell will report maximum 8 cells, and report interval is here. So we can check in RRC reconfiguration what is configure in their network, and after that we can decide what we can take action on the basis of event. So first of all, we should know the definition of A3. Event A3 is trigger when the neighbor cell becomes better than the serving cell by an offset, and offset can be either a positive or negative. The event trigger when the uh, following condition is true: written in green color, and written in red color. If we meet that time, network will cancel event A3. So, first of all, we should understand offset, and how can we calculate. Here we can see offset is equal to offset A3 offset plus offset frequency individual offset. So, uh, yeah, but here we can see in a left side snap only use A3 offset, frequency offset, individual offset is not here. This is used, generally not used. It's a special case is used when if you want to reduce boundary of the cell, that time cell individual offset is used. Suppose if you in handover criteria is defined minus, suppose threshold is minus 115, but if we want to reduce the cell individual offset, so we can reduce the value. If you want to stretch, so we can give increase that individual cell offset, and same like offset frequency is used on 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 frequency So it's a huge very rare cases. So generally this offset frequency individual offset is not used, but in a special case will use. So we should know, and during handover analysis you have to check if there is defined offset frequency individual offset on network or not. So it's a very important. Suppose without offset and individual offset is not used, then suppose offset is equal to only A3 offset. That means how can we can calculating, suppose here criteria. So suppose if serving sale is minus 150, and here minus 10 dB offset, and 2 dB is hysteresis is equal to minus 12 12 dB. And if we in a minus 12 dB, that means minus 103. If uh, yeah sale neighbor sale becomes 12 dB better than serving sales, that time network will trigger event A3, and we will send uh, measurement report against event A3 event A3, because offset is only defined 10 dB, but here hysteresis is also have 2 dB. So we can put all this in this formula, and we got meet this condition, that time event A3 will trigger. And yeah and below this condition is met, written in red color, that time network will cancel the event A3. So, conclusion is we need to understand offset, because suppose everybody say, and it's a misconfusion, says neighbor cell becomes better than the serving cell. No, serving cell by an offset, and but not if we adding not only offset, also if we consider during handover hysteresis. Hysteresis is used for the reduce the multiple handover instantly. Suppose this is called ping pong handover. So there in any places happen ping pong handover, that time you can increase hysteresis value. You got yeah solution of this problem. So I thank you for today. I will come with next video.